Okay, in this exercise, what we need to do is to find for which values of the function of the constant a, the function f is constant, right? We have to do that without computing the integral because, of course, in this case we can calculate the integral easily because the primitive of 1 over a squared plus t squared is related to the arctangent of t over a, right? I think it's 1 over a times the arctangent of t over a. But we are not going to do that because all we need to do to prove that a function is constant is to prove that the derivative is zero, okay? And finding the derivative of a function that is defined like this through an integral is just applying the Leibniz rule. So what we have to do is first to evaluate the integrand at the upper limit, so that's 1 over a squared plus x squared multiplied by the derivative of the upper limit, which is 1, and then subtract the function evaluated at the lower limit, which is a squared plus 1 over x squared, right? Multiplying by the derivative of the lower limit, which is 1 over x squared. Okay, if we multiply x squared by this denominator, what we have is 1 over a squared plus x squared minus 1 over a squared x squared plus 1, right? And if we cross multiply here, we have a squared x squared plus 1 minus a squared minus x squared divided by the two factors a squared plus x squared, a squared x squared plus 1. Okay, we don't care about these factors in the denominator because these factors are always positive regardless of the value of a, so we have to focus on the numerator and decide when the numerator is going to be 0 or not, right? So this a squared can be factored here, and you got is a common factor of x squared minus 1, right? And then you have plus 1 minus x squared, or if you prefer, minus x squared minus 1, like this, right? Doesn't matter how to write it, but in this way you can see that this is a common factor, and then you can express this as a squared minus 1 times x squared minus 1. And now you have to find which values of a make this expression identically 0 for any value of x. And of course, the answer to that is a squared equal to 1. When a squared is equal to 1, this is 0 and everything is 0 regardless of the value of x, right? So the two values for which this function is a constant are plus and minus 1, right? Actually, you can, once you know this, you can check it afterwards, because as I said, if a is plus or minus 1, then well, we know that this is just this primitive, right? And x here, it is this primitive, and then you have dt over 1 plus t squared, right? Which is the arctangent. So this is the arctangent of x minus the arctangent of 1 over x, of minus 1 over x. But since the arctangent is an odd function, this is what it is, right? So actually, the consequence of this is that this is a constant, which is something that we have already proven in the past when we were dealing in the topic of functions, I believe, right? Not only that, you can actually compute what is this constant by substituting x by 1, for instance, because then you have twice the arctangent of 1, so the answer is pi half. So this, not even that, not only that, I mean, you know that the answer to this is pi over 2.